transformations that occurred compared to the parent function, y equals the square root of x, for each of the graphs below. Then write an equation of the square root function, which includes the transformations you saved. Well, if you've been going through all of the graphs, again, I'm going to talk about the starting point here. Because usually where our graph starts is at 0, 0. So what I noticed in this one, when I just put it in blue, is the starting point now is at that ordered pair of 2, negative 1. Consequently, what that means is that we went right 2, and we went down 1. As I take a closer look, I want to look and see if there's any vertical stretch or compression. But from that blue point, we went 1 space to the right and 1 up to get that next point. And we went 1, 2, 3, 4 spaces to the right and 2 up. We did not stretch or compress at all. And now we can write our equation. It's going to be y equals the square root of x. Right 2 means that we're going to do minus 2. And then down 1 is minus 1. Inside the function goes the opposite way that you think that it's going to go. Letter B. First thing that I notice is that our graph is kind of upside down on this one. And what that means is that we have reflected over the x-axis. Second thing to point out, and you don't have to go in the same order that I went in, but our starting point, I just put it in orange over there, is at 0, 4. So that means that we moved up 4 spaces in this particular graph. And lastly, what I want to check for is, did we stretch or compress at all? And we, from our starting point, went 1 space to the right and 2 down. The down part is the reflect over. We went 2 down instead of a distance of 1 down. And consequently, that means that we have a vertical stretch by a factor of 2. When we write our equation, it's going to be y equals, and it's going to be the square root of x. And then we need to put some more information in here. Reflecting over the x-axis means that there's a negative out in front of the function. A vertical stretch, the up 4, means that we're going to have something outside of the function. And the vertical stretch is also an outside. We're stretching by a factor of 2. We went 1 space to the right and 2 down instead of 1 down. We went 4 spaces to the right and we went 4 down instead of 2 down. The down is the reflection. So just to write this equation just a little bit neater so you can see it, it's y equals negative 2 times the square root of x plus 4. Again, when I take a look at this one, I want to look at the starting point of it. And our starting point is way up here at 0, 5. In other words, we went up 5 spaces. It doesn't look like we reflected at all, but it does look like we have some sort of vertical compression. We need to look a little bit closer at that, just in terms of what it is. We went 1 space to the right, and it looks like we only went half up, but we can't really tell. It looks like it. So let's go our 4 spaces to the right. And 4 spaces to the right normally is going to be 2 up, but it's only 1 up. So we are vertically compressing by 1/2. And once we have that information, we can write our equation. Because it's going to be y equals the square root of x. The up 5 is an outside to the function. And our vertical compression is also an outside, and it's going to go out there in front. 1/2 times the square root of x plus 5. As we flip our paper over to finish here, we want to finish by writing an equation that describes the parent function y equals the square root of x, which has undergone the state of transformations. So we're kind of in this mindset of writing. So we were given the pictures and we had to write the equation. Now we're going to be given words and we have to write the equation. we just talked about vertical compression, only it was a stretch. It's going to go outside the function. So the 1/4 is going to go outside. Reflection over the y-axis means that we're going to have a negative underneath the square root. And then lastly, a shift up, it's outside the function, so it's going to be +6. Finally, 9b, reflection over the x-axis. Well, reflection over the y is inside the function, so reflection over the x is going to be outside of the function. It might be nice if I wrote my x there. Y equals the square root of x. I am going to have to erase a little bit here because I don't have enough space. Didn't do anything wrong. But the next part is vertical stretch by 3. That is outside. Whether it's a compression, whether it's a stretch, they're both outside. And left 1 unit is going to be inside the function. It goes the opposite way if you think it is. So it's going to be +1.